Next, we go to the series RC circuit. Muna na ta sa RL. So for series RC circuit, we can assume that our voltage is constant because di pa na siya inani, wala pa na siya. It's DC pa man. So V is constant. And then our charge Q is equal to 0, initial value. Okay, so muna itong first assumption because our source is VC. Source is constant. Now, applying the same to find the DE, we use the KVL. And then, so KVL, that's V minus VR minus VC equal to 0. Diba? So our V is, or we can rewrite the equation substituting the Ri minus our VC is actually Q over C, diba? From the value that we had earlier. And then remember our I is equal to dQ over dt, no? Change of charge with respect to time. So let us list this. So this is like V is equal to R times dQ over dt minus Q over C equal to 0. So again, folding siya, no? It's really foldy. This is minus. Pardon with my penmanship, but this is foldy because there is a derivative. There is the P here because of this Q, and this one is the Q of X. So let's just rewrite so we can have the standard form of foldy. We have dQ to be in the first line up, no? That's dQ over dt. So remove R, meaning this becomes the Q here becomes, this is positive na, this is Q over RC, or 1 over RC times Q equal to V over R. Okay, we equate everything with R para we can have a coefficient of 1 for this derivative. Gets nyo na? If not, you review what we had in the past. Now for our integrating factor, no, so IF, our integrating factor is e to the p, which is p is 1 over RC, no, times dt. So meaning our or our integrating factor is 1 over RC, e to the 1 over RC, or t. Now, in advance, you can tell that your tau is actually RC. Okay, so this is our integrating factor. So from here, just like earlier, the e to the negative r over L for inductor. So your tau is L over R, no? But here, your tau is actually, ano na siya, pangit ako pag-drawing. That's R times C, okay, for capacitor. Okay, just in advance, no? So we have a square speed x, sticks. Yes, speed x, square speed x sticks. So that's our y is actually Q now, no? Q, charge, Q times e to the t over RC, which is our integrating factor, equal to the integral of Q. Q here, that's Q of X, which is V over R, times E, the integrating factor, RC times dt. Okay, so we integrate Q of E t over RC. This is V over R times RC, no? RC. Okay, this one is 1 over RC. Pag integrate, this is the becomes the denominator, then reciprocate, this becomes RC times e to the t over RC plus C. Okay, so we can cancel R here. What's left is just V times C, or VC. And then, sige lang, rewrite muna tayo. E t RC equal to VC times e to the t over RC plus C. Karon, there's a common, we can eliminate this, and then it becomes kuan here, times e to the negative t RC, no? So Q equal to VC plus C times e to the negative t over RC. Now, we need to find C, di ba? This, para di ta ma-confuse, this C is the arbitrary constant, so we can just put here C1 para di ta ma-confuse. Our C here with beside V, the multiplier of V is capacitance, so let's just put C1 here. So we need to find C1 at the initial condition kini. So our Q is 0 equal to V times C plus C1 e to the 0, which is just 0, so meaning our C is equal to negative V C. Okay, then rewrite the new equation. The Q, or the particular solution, equal to what's that? This one, VC plus negative VC. So it's common, so we can do this 1 minus, common man siya, and then when we distribute the same value, 1 minus e to the negative t over RC. Ayan, that is our particular solution for this circuit. Tama ba? CV, VC, the same. It's our particular solution. Then, what is our current here? So, I is what? The differential of this dq over dt, no? Kani, kani. We're looking for the current dq over dt, so we just have to differentiate this one. So I of t is equal to, if you're looking for the current na dayon of the circuit, so this becomes V over R, because tama ba ko? Yeah. No, let's just not shortcut it very shortly, kay kuan man gyud siya, you might get confused. So we copy this is constant, so this is VC times this one, the derivative of this one, it's e to the negative e to the negative t over RC times the differential of this denominator, which is negative 1 over RC. Ayan, so muna siyang na-eliminate ang C. Okay, so simplify this, remove this C here. What's left is just a negative times negative is positive, so our I of t actually is equal to V over R times e to the negative t over RC. So this is our equation of the current in a series circuit. So you notice lahi na yung nature, no? As t approaches to infinity, dili na siya going to steady state, but t equal to 0, meaning open circuit siya. Okay, so in series RC circuit, there's no such thing as steady state response, and it's actually an open circuit. So if you're not aware yet with the term DISCO, in DC, the inductor is short, the capacitor is open. Okay, inductor is short, capacitor is open. That is DISCO. Okay, so what is the VR and VC for this circuit? So the VR is RI, diba? So the value of this times R, so is equal to R times V over R e to the negative t over RC. Dali ra. So we cannot simply just multiply, no? We need to find that particular solution for this. So moagi jud kag DE. So VR equal to, eliminate this, it becomes V times e to the negative t over RC. Ayan. So kaniha, again, this is very useful. You can use this right away. Nakakuha naman ta, derive. Then what about VC? VC is equal to ini, Q over C. Q over C. We have a given capacitance. And then we have Q. Aman tong Q na to. This is our Q. Ba to? Dara. This is our Q. No? So, we can substitute this Q here. VC times 1 minus e to the negative t over RC over C. Cancel ni siya. This is capacitance, ha? So, VC is actually equal to V times 1 minus e to the negative t over RC. Yan. So, this is our equation for VC, equation for VR. So, importante ni sila, ha? Equation for the current, equation of the charge. Particular solution. Okay? When you try to derive this and then master it, di naman problema pag-abot sa inyong circuit theory. Okay? Then the curve here, if you notice sa ato ang inductor, inani man siya, no? Inani siya. But here, pabaliktad. Because again, this serves like a wire, no? Sa DC, this is like a short circuit. Short circuit meaning naa siya nagflow nga V over R. But for this one, for capacitor, pabaliktad. The curve actually is panaog, no? Walay current. If we have this I here and this is our T, this is V over R. Gikan sa V over R siya, munaog siya, no? Until T approaches to infinity, it becomes 0. Okay, so this is for our I of T for capacitor. Okay. Go to the example for ato ang capacitor. We have this 10. So, this is 10 UT. Unit step man siya. So, I lang nag-mind. It's just 10 volts DC. 100 ohms and 1 millifarad. Farad is the unit for capacitance. Now, we're looking first for the tau or time constant. Then B, we're looking for the equation of the current I of t at any time or at any given time. C, we're looking for the value of I, VR, and VC at t equal to 250 millisecond. And D, what is the time? What is the value of t or time when VR is equal to VC? So, kind of similar atong prior example. So, let's start with letter A. So, letter A, we have time constant. We know that time constant for capacitor is RC. So, meaning, we just multiply, no? 100 ohms times 0.001 farad. So, that is 0.1 second. So, muna yung time it takes for the kuan to reach the actually sa capacitor atong 63. Oh no. For capacitor pabali, the time it takes or time required for the response to decay na siya. Remember, paana man siya, no? Paana man siya. The 1 tau here is the time it takes for or time required for the response to decay at 36.8%. So this is nandilapit 36.8% before siya mahimong 0. Okay? Okay, so we'll proceed na. Letter B, equation of IT. Equation of IT. Kanina, we have IT already. So, no need to kuha na. Kabalo naman mo. So, that is actually the important part katong you learn to derive based on the law, no? The principle or KVL arriving with a folde. So, kung kabalo ka sa process sa folde, you can have the integrating factor and you can substitute with the yes pdx squares pdx dex and then proceed na rin ka. Then, makuha na nimo ang ato ang current or ang ato ang charge. Then, kato na yung mga particular nga mga values ang ipangita. Okay? And so this is V over R times 1 minus e to the negative, dili mo ko itong isa ni siya. So, we have to be familiar kay masayo po niya taani in this part, that is e to the negative t over rc. So, when you try to memorize, muna dyan na yung nature. So, our I is equal to 10 over 100 times e to the t. We don't have the t, but we have the rc. rc is, that is then equal to negative t over 0.1. Mo naman eh. Okay, so our I then, the equation at any given time for this circuit is 0.1 e to the negative 10 t. Yan. So this is our equation of the current at any given time for the circuit. Letter C, we have, we're looking for the current, the VR VC at t equal to 250 milliseconds. So we'll not be using, but we have this I that we can just substitute, no? What is I at t? So nara di ay siya. I is equal to 0.1 e to the negative 10 times 0.25 millisecond or 2 seconds. So I is equal to 8.1 milliampere. So muna itong current at ana nga time. We have, we're looking for VR. VR is equal to RI, no? Where our I is this one na, no? The same time man. So, diretso na. Sayo naman day ni. Times 8.1 milliampere. So, VR is equal to 0.881 volts. And then, what is VC? VC is equal to V minus VR. Okay, sila ramang tulo din hi. So, that's 10 minus 0.8 V, 81 V. So, ay mo kalimot on your final answer, there should be units. Especially that we have these kind of mga particular nga mga value of the components. So, this is 9.179 volts. Okay? Letter D, we find the value of T when VR is equal to VC. So we can equate the equations for VR and VC. That is VR equal to VC. That is V times e to the negative t over RC equal to V times 1 minus e to the negative t over RC. So kind of duol-duol ra sila tong sa inductor. So this becomes cancel. This one is negative, we move it there, so it becomes positive. This becomes 2 e to the negative t over rc equal to 1. And then we move to the other side, 1 over 2. Then we can ln, no? ln of e to the negative t over rc equal to ln of 1/2. So we can eliminate this. We have t over rc. So t should be equal to t over rc. This is ln of 0.5 over 10, which is negative 10, which is equal to 69.3 seconds. So, uning time nga mag-equal ang VR of VC. Okay? Very well. Sayo na raday kayo. Basta na lang tayo formula, no? As long as we understand what's in the formula, because it may confuse you. Kay some of the equations, there is 1 minus E. Others don't have that. And then, for our capacitor, that's T over RC. And then, sa atuang kwan is R over L times T. So, you have to be very familiar with that. So, practice. Okay, we go to this example in which ang atong RC circuit, ang source is an AC. So, medyo challenging ni siya. And what was needed in this equation is we determine the I at any given time. Current man siya. So, what do we do? So, Ato ta sa KVL, our corresponding equation is V is equal to Ri plus Q over C, no? The voltage across the capacitor. Karon, since we need I of t, so we need to express everything is as a function of t with respect to, or a function of, or I with respect to t, no? So, saan man nato ni? So, we need to derive this para naatay di over dt and everything. So, when we derive this becomes dv over dt equal to r, which is a constant, times di over dt. So, d over dt. And then plus 1 over c. Q is being derived. No? And we know that this dq over dt is I. So, kanina lang atong problema. So, with this given value, we can derive this. Okay? So, before na nato buhaton, since di dt man ang ato ang playing ko andiri, no? Mo itong naka-play sa major role, we have to have the coefficient into 1. So, we divide everything with r. So, let's rewrite nga di dt mag-una. So, di over dt, r lang sa, no? That is plus 1 over c I na ta. Sige, let's just put it as I na lang. Diretso. I equal to dv over dt. So, medyo change lang na ko, no? And then, let's divide everything with r. 1 over r. Cancel. So, this becomes di over dt plus 1 over rc. I equal to 1 over r times dv over dt. So, r is actually 100. Sige lang. Hinahinay na itong substitute. 100 times dv over dt. That is 10 cosine. So, let's just shortcut na lang, no? That is 10 times, what is this is negative sign, sine pi t times the derivative of pi t is still equal to pi. Okay, so this is 1 over ana siya. And so di over dt plus 1 over 100 times 1 millifarad. 100 times 0.001 I, so let's just move this as I, equal to negative 0.01 sine pi t times pi. Okay, and then simplify pa na to. Our di over dt a plus becomes 10i actually equal to negative 0.1 pi sine pi t. So, what is our integrating factor? So, this is our px, no? So, if this is in folde. Then, this is e to the integral of 10 dt. So, it becomes e 10t. So, this is our integrating factor. So, our y here is actually, or dependent variable is I. So, I times integrating factor equal to integral of q, which is negative 0.1 pi sine pi t, no? Times the integrating factor e to the 10t dt. Ayan. Diba? So, we integrate this e to the 10t equal to, so the actual here becomes negative 0.1 pi, which is constant, times e to the 10t over 10 squared plus pi squared. How many gikan? Chan. Where did this come from? Sine pi t minus cosine pi t. Okay, simplify I. So we can eliminate this kay same sila and then add it here, e to the negative 10t. Then with our initial conditions, the current is 0 at time equal to 0. Also Q equal to 0 at time equal to 0. Okay, so from the initial condition, we'll have then R times dito mag-base here, bisa diri R times I of 0 plus Q at 0 equal to 0 equal to V of 0. Okay, and so shortcut lang siya because the equation I is very long. So this becomes 0, and then you will have like I at 0 is equal to V at 0 over R, which is equal to 10 over 100. That is 0.1 ampere. Yan. Shortcuts lang siya. Okay? Now, we have 0.1 ang atong A. So, we need to find C. C. Where is C? So, our I is 0.1. Considering the very long equation. This very long equation. It will become like 0.1 pi squared over 100 plus pi squared plus C. So our C, if we calculate, use calculator, C is equal to 0.91. So rewrite the equation. We will have, oh my god, very long. Just write it up here. I of t is equal to 0.1 pi over 100 plus pi squared times pi cosine t, pi t minus 10 sine pi t plus 0.091 e to the negative 10 t. So this is our current. So as long as you know how to evaluate the equation, no, mag-formulate ka og equation DE, and then you know folde, wala kay problema if your circuit will look like this, no, regardless of the value. And of course, always remember this equivalent. Asa na ko rin nakuha? Remember,